The crane and grab company Ridinger became in 1997 Greifer GmbH, founded by former employees. The company specializes in the production of grabs of every kind and is located about 100 kilometers south of Frankfurt, not far from Heidelberg. When the customer has submitted his order, work begins in the technical department. Here, drawings and designs for the production of the grab are produced. Using modern CAD equipment, experienced technicians create three-dimensional projections of individual grab components, which are then assembled. Here we see the simulated operation of various types of grab. For example, the motorized rectangular grab with 9 shells, or the motorized round timber grab. A CNC AFC-controlled bandsaw and frame saw automatically and economically cut to size the axles, bolts, bushes and bearing components. Universal lathes for programmable cycles are used in a variety of ways. For example, for large-scale production runs or the conventional turning of one-offs. Whatever the job, precision is the watchword. The horizontal drilling and milling machines are equipped with the finest tools for the precise axial and radial working of all drillings and fittings of the various bearing points, whether big or small grab components. All forms of hollowings, insertions, slots and reductions for sealing systems can be produced. Modern CNC-controlled flame cutters cut to size steel sheeting of various thicknesses and qualities. The particular component forms are first defined on computer in the technical department and then allocated to the appropriate cutting machine. The precision-cut components are cleaned, the welding seams prepared, brought together according to the design, tacked and mag-welded under the supervision of a specialized welder. Highly qualified technical staff is the guarantee of top-quality manufacture. Here we see excerpts of various assembly procedures, hydraulic components for motorized electro-hydraulic grabs, the high-pressure axial pumps and the control blocks. The lower grab rod bearing is installed on this 4-rope orange peel grab. After completing assembly, the employees of Greifer GmbH carry out the initial function check. The pressure of this motorized clamshell grab is checked and tested. A look at the highly organized spare parts store. A wide-ranging assortment of hydraulic parts ensures immediate availability when required. After assembly, this 4-rope orange peel grab is transported to the paint shop. First the anti-corrosion primer, then the painting. Wherever possible, the company welcomes customer wishes regarding paintwork, even including the thickness of the primer and the final coat. A motorized rectangular grab with 9 shells is ready for delivery. Just time for a final check. This machine will be handling scrap, round metal and round timber. After a complete overhaul, this 8 cubic meter motorized dredging grab with a dead weight of 12.5 tons is loaded up for collection by the customer. In Mannheim docks, we see an MRS 4-rope orange peel grab handling scrap. The lower grab rod bearing and the lower rope pulley block bearing are cardanic, which enables the grab to adapt optimally to the material being moved. The open design of the grab shells is best suited to this bulky grade of scrap. Here in Stuttgart docks, scrap is being transferred also using a 4-rope orange peel grab. All the bearing points are cardanically operated, but here the grab shells are a closed design. In Stuttgart docks, as elsewhere, different sizes of paving stone are unloaded. 4-rope orange peel grabs are suitable here too, as long as the bearing points are cardanic. Motorized electro-hydraulic orange peel grabs are excellent for moving stone. This grab, shifting paving stone in Plochingen docks, has a capacity of 3 cubic meters. Filling is optimal thanks to the even distribution of pressure over the grab shells and hydraulic cylinders. The material grabbed, be it stone, scrap or whatever, doesn't fall out while being transported because the pressure is distributed evenly via the grab arms. This even distribution is not the case with the rope-driven grab. Here we see a number of 4-rope clamshell dredging grabs, 5- and 7-fold hauling with variable dead weights. The weight and solidity of the material to be handled determine the design of the grab, the hauling, the dead weight, length and shape of the teeth, and whether the grab will have 2 or 4 shell pivots. Abrasive materials like sand or gravel require extra durable blades, particularly the edges. Motorized electro-hydraulic dredging grabs are also used to excavate sand or gravel. To some extent, this special grab equipment has recently pushed the rope grab off the market, because the hydraulics achieve a greater closing force and optimal excavation efficiency. The special MRS design with its open traverse construction does sterling service. The control panel and the connections for measuring instruments make it easy to regulate the pressure. MRS Grabs GmbH is a world leader in this grab equipment. Over 500 motorized dredging grabs are in service all around the globe. Around the clock, the ANBW AG coal-fired power station at Rheinhafen Docks Karlsruhe employs 3 MRS 4-rope clamshell unloading crane grabs with a capacity of 15 cubic meters. The grabs are environmentally friendly and maintenance-free. The careful tuning of the fully automatic crane controls has permitted a relatively small dead weight for the grab, and therefore greater efficiency in the unloading of slag. Correctly handled, the environmentally friendly shells prevent loss by scattering or blowing. The coal-fired power station in Heilbronn operates 3 4-rope clamshell unloading crane grabs of standard design, capacity 12 cubic meters. Here at Stuttgart's coal-fired power station, 3 grabs of the same design are at work, capacity 5 cubic meters. As we can see, depending on the loading situation, open shells lead to the grab severely overfilling, resulting in coal heaps with a slope of up to 50 degrees. This can easily cause losses during transport due to scattering. The Neckarwerke Stuttgart processes all the refuse from Stuttgart and the surroundings. Here we see a motorized electro-hydraulic clamshell refuse slag grab with exchangeable teeth, capacity 4 cubic meters. Generally speaking, refuse slag solidifies very quickly and hardens. Depending on the amount of scrap present, it is then difficult to grab the slag out of the bunker. Specially designed grabs are of advantage here. Thanks to hydraulics, motorized grabs provide stronger closing force and greater flexibility of use. An MRS 4-rope clamshell grab, capacity 3 cubic meters, moving refuse slag at the refuse incinerator in Ludwigshafen. Rope grabs too must be expertly designed for slag transport to achieve an acceptable filling of the grab. Powerful closing forces improve efficiency. The MVV Mannheimer Müllverbrennung represents state-of-the-art refuse processing and incinerates the refuse of the whole Rhine-Neckar region. In the various refuse bunkers, 2 8 cubic meter capacity and 3 5 cubic meter capacity 4-rope orange peel refuse grabs are in constant use. The first refuse incineration plants were built in Germany in the 1960s. At that time, clamshell refuse grabs with capacities from 2.5 up to a maximum of 5 cubic meters were used. As the refuse became ever more bulky, orange peel grabs offered the better solution. The capacities of the incineration plants were also steadily expanded, so that nowadays refuse grabs with a capacity of up to 15 cubic meters are not unusual. Here is an MRS 8 cubic meter grab in the refuse bunker in Mannheim. Moving round timber, with a gantry crane equipped with a rotary winch and an MRS motorized round timber grab, 2 square meters capacity. This plant is located in Großwaldstadt, near Aschaffenburg. Today, many timber yards and loading docks are equipped with modern motorized or rope-driven round timber grabs. MRS round timber grabs with a capacity ranging from 0.3 square meters to 6 square meters are found in many docks and timber yards. MRS products with their tried and tested designs are clear favorites thanks to their optimal efficiency in moving materials.